Okay, so this example is asking us to look at two different professors teach an introductory statistics course. The table shows the distribution of final grades they reported. We wonder whether one of these professors is an easier grader, and the results are here, and I have used this to copy copy table to clipboard. Let me show you what that is. I have to do this. If I do this, it gives me the option to copy table to clipboard, so that I can then paste it in Excel, which I have done here. Alright, so we're going to need that later on. Will you test goodness of fit, homogeneity, or independence? If we look back at this slide and just try to simplify it, what we have a situation where there is one group and one variable. So it is going to be goodness of fit? Absolutely not. There's not one group. There's a group with Professor A or Alpha and the group with Professor Beta. So it cannot be a goodness of fit test. There are two groups, so several groups. This condition is met. There's one variable, which is grades, and we have multiple grades, obviously, but don't confuse multiple values for one variable with multiple variables. Alright, so we are going to be using the homogeneity test. Alright, so the appropriate hypothesis is what we're being asked to choose, and you want to focus on the two groups being the same as the null. What about the groups? Are we looking at the grades? So the distribution of grades is the same for the two professors versus the alternative. Not that one professor is better than or higher than. We're not going to be going into that. We're just looking at a difference. The distribution of grades is different for the two professors. Is the alternative hypothesis, while the null is saying the distribution of grades is the same for the two professors. We're asked to find the count, expected count for each cell, and explain why the chi-squared procedures are not appropriate. Now let's go to our Excel sheet. This is the information we were given, and in order to get to where we need to go, let's go ahead and create some other values. We want to see the total amount of A's that the professor gave, the two professors, and also the total amount of B's, C's, D's, and F's. Alright, so that's the total. Now if the expected, in these two columns I'm going to have the expected counts if the two were equal. If the two were equal and we had 14 students getting A's, then this professor would have half of that amount, and this professor would have the other half of that amount. Alright, and we can do the same. So I highlight these two cells, get the handle, and copy it down. So what we're saying is if the expectation is correct in that our null hypothesis that the distribution of grades is the same, it would mean therefore that of the 14 students getting A's, we would have half from Professor Alpha and half from Professor Beta, and the same for the rest. Now the problem comes up right here, where the expected amount for this cell is 2.5 and for this is 2.5, which is not equal to 5, which the text suggests that it has to be. So for that reason, we cannot use a chi-squared procedure because they are not appropriate based on the data that we have. Alright? Hoping that this helps. If not, please feel free to reach out to us.